Morning, one and all. In today's class, let us cover the topics of Unit 2 of Automobile Engineering. Unit 2 consists of cooling system, ignition system, and electrical system. And this is our syllabus: cooling system, cooling requirements, air cooling, liquid cooling, thermo, water, and forced circulation systems, radiators, radiator types, cooling fan, water pump, thermostat, evaporative cooling, pressure sealed cooling and anti-freezing solutions. Next is ignition system, functions of an ignition system, battery ignition system, constructional features of storage battery, auto transformer, contact breakers, breaker points, condenser and spark plug, magneto-coil ignition system, electronic ignition system using contact breaker, electronic ignition using contact triggers, spark advance and spark retard mechanism. Next is electrical system, charging circuit, generator, current, voltage regulator, starting system, Bendix drive mechanism, solenoid switch, lightning system, horn, wiper, fuel gauge, oil pressure gauge, engine temperature indicator, etc. So, in this class, we are going to learn about all these things. First one is cooling system. Cooling system is an apparatus employed to keep the temperature of a structure or device from exceeding the limits imposed by the needs of safety and efficiency. So here, to understand it very simply, a cooling system is here a water cooling system or a air cooling system. Here the radiator is a main part of the cooling system. So here what happens is during the uh, uh, combustion process, excess of heat will get released in the engine, and because of that excess heat there are more chances that the parts of engine may get damaged, or else the lubricating oil may get evaporated. So here, in order to control the heat that is released during the combustion process, we supply air or fuel to control the uh, uh, energy released. So here the system which is helping to control this energy is called cooling system. The necessity of cooling system is engine and engine part should not reach its melting point. Generally the energy which is getting released is too high that it will melt the parts present in the engine. So because of the cooling system, as the temperature is under control, these parts are working properly. Next is preventing the lubrication oil from getting oxidized. It means if temperature is too high, the lubricating oil will get oxidized, and the rupture of parts will take place. Next is higher temperatures will decrease the efficiency of the engine. So because of these reasons, we are having a cooling system. And the requirement of cooling system is it should take out only 30% of the heat, because even if it takes more than that or less than that, the efficiency of the engine will get reduced. And next is the rate of removal of heat should be at faster rate. It means it should cool the engine very fastly. So in this process we have different types of cooling system. First one is air cooling system. In case of air cooling system, you will have fins like this, and the purpose of fins is to increase the contact area. The heat generated here in the fuel tank will get supplied to the fins, and these fins will be in contact with the air, and as the surface area got increased with the help of fins, the rate of heat transfer is also high from the engine to the surroundings. As a result, the cooling will take place. As there is no other system, because in case of water supply system the construction is too heavy, here the construction is very light, so the weight of the system is also reduced. This air cooling system is generally used in our bikes and in the cars and automobiles that we use in cool areas, like where you have very less temperatures. In such cases we can go for air cooling system. Next one is liquid cooling system. In case of liquid cooling system, we uh, we use water for cooling the engine. So this is the engine cylinders, and here you have the jackets from where the water will pass inside. So here see, this blue color is the cool water getting entered into the engine cylinders, and the means outside the engine cylinders, and this is the hot water coming out from this lining and getting into the radiator. So this radiator is of different types. So here this block which we are seeing here is the radiator. This, as I told, these radiators are of different types, but here the to understand this diagram, um, here is the circulation of water, and this is the fan which is rotating and pulling this air. The heat will get transmitted from this water to air, and this water will get cooled down, and this cooled water will enter into this cooling system again. So now these radiators are of different types. Let us look at these radiators. Uh, that we'll see next slides. Next is thermosiphon cooling system. Here we have to remember one concept. The components, sorry, the matter with higher densities will be settled at the bottom, and the matter with light density, lower densities, will be at the top. So here what happens is, hot water will be at the top, means it will get evaporated, it will go top, and the cool water will again come down. So here what happens is, here in this engine block, the cool water will get supplied to the engine, and the hot water will get evaporated to the radiator. The radiator will again cool down this hot air, this hot water, the evaporated water, with the help of air, and again it will send back the cool water to the engine system. But this thing is here, this system is not that efficient, because the temperature difference may not be too high. It means the efficiency of the system is comparatively low than the previous systems which we have seen, the liquid cooling system which we have seen. This is a forced circulation system. Just what I have explained in liquid cooling system, the same concept is here. This is the engine, this is the radiator. Once the coolant, it means the water which is present, reaches a particular temperature, the thermostat valve will sense that, and it will get open. As a result, the water present in the engine will go to the radiator, and once the water gets cooled, the same water will be repumped to the engine. These are the different types of radiators. First one is grilled tube radiator. So here this is the intake manifold, and this is the output manifold, and these are the tubes. So now the water will enter from this, and it will go through all the tubes which are present in the radiator, and once it gets cooled, means air will pass from this, and once the water gets cooled, it comes out from the outside manifold, and it gets supplied to the engine. Similarly, this is the tubular radiator. Here in case of tubular radiator, the water will pass to these fins, the vertical linings, and these are the fins. The fins are used for increasing the contact area. Here the heat from the water will be supplied to the fins, and these fins will cool the water because of circulation of air, and this water will be resent to the uh, engine unit. It means the jackets, air's cooling system. And this is a honeycomb radiator. Here you have some hexagonal shapes. The air will enter from this hexagonal shapes, and water will come through these linings. So here the heat transfer will take place from the water to the air, and this cooled water will be resent to the radiators. So resent to the engine systems. So these are the different types of radiators which we use in the cooling system. And next is evaporative cooling. The hot water will get evaporated, and when air passes through it, it gets cooled, and cool air will again come out, and it will be supplied to the engine. The hot evaporated air is coming to radiator. The cool water will again send it to the cylinder block. So this is how the evaporative cooling will work. Next one is pressure sealed cooling. It means we don't allow the pressure to go out from the system. So here what happens is, as the pressure got sealed, the temperature will get increased very fastly. So here also the same concept, but here the circulation of water will take place very fastly. This is the safety valve, and this is the vacuum valve. This will get open if pressure increases too high. So here what happens is, when pressure is means because of pressure the temperature variation will take place very fastly. So here also the same concept, the light water will get evaporated and get into the radiator, and the cooled means the hot water will get entered into the radiator, and the cool water will be resupplied to the engine. Next one is anti-freezing solutions. It means the water which is present inside should not get freezed during the cool conditions. So that's why we use anti-freezing solutions in order to keep the liquid at liquid stage. So these are the different types of anti-freezing solutions, like alcohol, glycerin, ethanol, glycol, propylene glycol, and mixture of alcohol and glycerin, various mixtures of other chemicals. Next one is ignition system. The system in an internal combustion engine that produces the spark to ignite the mixture of fuel and air. It includes the battery ignition coil, distributor, spark plug, and associated with switches and wiring. In case of internal combustion engines, we have spark plugs for two-stroke engines, and for four-stroke engines we don't have spark plug. There we go for compression ignition. Wherever we go for spark ignition, there we have ignition systems. So we have different types of ignition system. First one is battery ignition system. In case of battery ignition system, this is the battery and this is the blast made with iron. So here when the switch is on, the circuit will be closed, and the electric supply will start from battery through the blast. If the voltage is too high, the blast will also increase its resistance. It means so that the other circuit will be saved. So here you have two types of windings. The outer one is the primary winding and inside one is the secondary winding. The electric supply which you are getting from battery will first go to the primary coil. From primary coil, this energy will go to this contact breaker. So here the blue color one in the rhombus shape is controlled with the help of camshaft. So when it is rotating, this will come in contact with this trigger. As a result, the circuit will get closed. When circuit gets closed, the reverse EMF means the current will flow in reverse order and the secondary circuit will get activated, and this is the capacitor. The purpose of this capacitor is when this is coming in contact and again moving back, when there is a small gap between both the electrodes, there are chances of getting the spark. So the capacitor will help in avoiding these sparks. So now when this is coming in contact, the circuit will be closed, and when it is coming out, that means when it is breaking, the circuit will also get break. So this is how the battery ignition system will control. So here the electric supply will be from this contact breaker to the distributor. So in the distributor you have a trigger like this. So here what it does is, if it is in contact with the first one, the first spark plug will ignite. If it is in contact with the second one, the second spark plug will ignite. If it is in contact with the third one, the third spark plug will ignite. So like this, depending upon its contact, the ignition will take place. But here in case of spark plug, we have a positive electrode and a negative electrode. There will be some gap between both the electrodes. When gas passes through it, because of ionization of gases, a spark will produce, and this is how the spark ignition system will work. So here we use battery for starting the engine. Once the engine gets start, the battery will regain its energy. It means it will be recharged back when engine once starts rotating. So this is about battery ignition system. Next one is magnetocoil ignition system. Here either the coil will be rotating or the magnet will be rotating. So this will be connected, this magnet will be connected to the shaft. So when this is rotating, a EMF will produce in this coil. As a result, the current supply will start. So now when we on the battery, the ignition system means here the circuit will be closed, and when circuit is closed, this is the electricity will pass here. So this is a camshaft. When it is rotating, this contact will means when it gets contact, the circuit will be closed. Here also you have a condenser to control the spark that is produced here between both the electrodes. And now this electric supply which you are getting will be supplied this to this rotating arm which is present in the distributor. This rotating arm will go in contact with the uh, switching to the circuit which is connected to the ignition system. It means for the spark plugs. So now if it is in contact with the first one, the first spark plug will ignite. Similarly, the 1, 2, 3, for all the things which you have. So now depending on the position of the camshaft, this rotor arm will take its position and ignite this spark plugs. Here also you have both positive and negative electrodes, and because of ionized gas passing from this spark plugs, the ignition will take place. This is about magneto-coil ignition system. And next one is constructional features of storage battery. This is the storage battery. One side of the electrode is made with lead, and this is the lead oxide, and this liquid which is present here is H2SO4. And here what happens is when PbO2 is present, the hydrogen will move this side, and sulfur molecules will start moving this side. This will become all positive side, and this will become negatively charged, and electricity will start flowing in this direction. And once the engine starts, the battery will start getting its energy, and as a result what happens is it will start get the hydrogen and sulfur molecules will again react, and because of the heat produced, the water present here in the mixture will get evaporated, and this H2SO for concentration will increase. That is the reason why we pour water into the battery. It means into the storage system. So this is how the battery works. So the hydrogen will react with PbO2, that is lead oxide, and sulfur will react with lead. So as a result, um, the positive and negative electrodes will be created, and electricity will pass through this system. Next one is electronic ignition system using contact breaker. This is the armature which rotates with the help of camshaft, and this is the magnetic pickup. So when it comes in contact, this will take the electricity. This is the engine control module. This is the battery. Battery is a power supplying unit, and this is for switching on and switching off the power supply. Engine control unit will control everything which is present in this system. This is the ignition coil used for igniting the mm, spark, and this is a distributor to distribute the spark evenly. So here is the spark plug. Here you have a positive electrode and negative electrode, and because of ionization of the gases, the spark will come. It means as there is small gap between both the electrodes, because of the resistance offered by the gas, the spark will come. So here when camshaft is rotating, and when it comes into contact with this magnetic pickup, this will send that to the engine control unit. When the engine control unit receives this signal, it will send it will make the ignition coil to work. As a result, this ignition coil will be this power from the ignition coil will be sent to the distributor, and distributor will send the energy to the spark plugs. And once, as I told, once the engine starts, the battery will start gaining its energy back. Next one is electronic ignition system using contact trigger. These are the triggers. This is the camshaft, this is the crankshaft, and this is the camshaft. This is the triggering wheel. So now when this wheel comes in contact with the sensor, this is the cam position sensor, this is the crankshaft position sensor. When these two sensors give signals to the electric control unit, the electrical control unit will give signal to ignition control module to ignite the spark plugs. Here is the battery to supply the required electric supply, and this is the ignition system for switching on and switching off the power from the battery. Next one is spark advance and retard mechanism. It means if sparking of fuel, it means burning of fuel is taking place before then we require, then we call it a spark advance. Spark retard mechanism is if the spark is coming after the requirement. It means spark advance is getting spark in advance before the ignition is taking place, before the time it have to ignite, and spark retard is igniting later, means after the requirement. So like this, so here spark advance and retard mechanism is controlling the spark. So here you have a camshaft, these are the springs and these are the weights, and now what happens is when cam is rotating with high speeds, because of the weights, this these weights will move outside. As a result, the spring will get elongated. In this process, this will give the mm, signal to the spark to get ignited. So this is how the spark advance and retard mechanism will work. And in the next slide, in the next class, we'll learn about electrical system. Thank you for listening.